In September 1939, new types of military hardware appeared on the roads of Poland. Polish soldiers found themselves facing machines of an unusual design, half-track hybrids featuring a wheeled front axle and a track drive in the rear. These vehicles, protected by sloped armor, delivered troops directly to the front line. This marked the first combat application of the German armored personnel carrier, Sd.Kfz 251, a machine that would eventually be used across a vast territory from the Atlantic to the Volga. Development began in the mid-1930s, when the German command concluded that tactics needed to change. The concept of rapid warfare required infantry to move in sync with tank formations, rather than following behind in ordinary trucks, which were vulnerable to enemy fire and offered no protection to the personnel. A fundamentally different technical solution was required, combining protection with high cross-country ability. The answer was to combine the characteristics of a tracked tractor with the maneuverability of a wheeled automobile. In 1936, the Hansa Lloyd firm, part of the Bussing concern, presented a prototype designated HR-6. The machine was distinguished by the characteristic angular shapes of its armored hull and an open top. After the concept was approved by military clients, the rights for mass production were acquired by the Hanomag Company, which possessed the necessary capacity. Engineers used the chassis of the mass-produced Sd.Kfz 11 artillery tractor as a base, which allowed them to utilize components already proven in service: the engine, transmission, and running gear. In the summer of 1939, shortly before the start of major hostilities in Europe, assembly of the first production batches began at factories in Kiel and at Borgwood facilities. The manufacturing process involved creating welded and riveted hulls. Welded versions were made from heterogeneous armor, while riveted variants were sometimes made from structural steel to speed up production. From September 1st, German troops used the Model A modification, equipped with additional vision ports on the hull to improve visibility. 10 men were housed in the open-top troop compartment. Side armor thickness was 0.3 inches, and frontal armor was 0.6 inches, providing protection against rifle-caliber bullets and shrapnel. A 6-cylinder Maybach engine with 100 horsepower accelerated the machine, weighing about 3 tons, to 33 miles per hour on the highway, while the track drive ensured mobility over rough terrain. The driver and radio operator sat in the front under a roof, while the rest of the troops were stationed in the open rear section. The Polish campaign, which lasted 27 days, confirmed the viability of the concept. Armored personnel carriers allowed infantry to be delivered rapidly to enemy positions. However, analysis of combat use revealed design flaws. An excessive number of vision slits weakened the hull without giving a significant advantage in real conditions. In the winter of 1939, the Model B modification was introduced, where vision devices remained only for the driver and radio operator, and the radio antenna was moved to the upper front plate. Simplifying the design increased the reliability of the equipment, which was deployed in the spring of 1940 during the offensive in France and the Benelux countries. During the campaign, the Sd.Kfz 251 proved highly effective in the field. Tank units would punch through defensive lines, and the motorized infantry followed in their half-tracks to secure the gains. The speed of redeployment and the ability to keep the troops physically fresh after a march became a significant tactical advantage. Thanks to its half-track drive, the vehicle successfully tackled difficult terrain, including the dense forests of the Ardennes. The design, with its wide tracks and front wheels, provided the necessary traction, while a 42-gallon fuel tank allowed for a range of up to 185 miles without refueling. The French campaign ended in 6 weeks, which confirmed the effectiveness of the mechanized infantry concept for the Wehrmacht command. Additional production capacity was brought online. In early 1941, the Czech firm BMM began producing high-quality riveted hulls. At the same time, engineers introduced the Model C modification with a redesigned nose. Changing the angle of the armor plates improved protection against bullets without increasing the thickness of the metal. On June 22, 1941, with the start of Operation Barbarossa, about 1,000 Sd.Kfz 251s were sent to the Eastern Front. Conditions in this theatre of war were vastly different from Western Europe. Huge distances, a lack of paved roads, and active resistance from Soviet troops. Steppe dust, autumn mud, and freezing winter temperatures put a heavy strain on the equipment, yet the machines kept running. The design's versatility allowed the half-tracks to transport infantry, tow anti-tank artillery, and haul ammunition. The open combat compartment exposed the troops to the weather, though crews used canvas tarps for cover. But this layout allowed for rapid dismounting. The command versions were particularly important, equipped with extra radios and frame antennas. These vehicles functioned as mobile communication nodes, allowing officers to coordinate units while staying inside a protected hull right in the combat zone. The enemy learned to identify command vehicles by their antennas, concentrating their fire on them. Operations on the Eastern Front revealed a significant design flaw in the half-track, the open top. The troops inside were vulnerable to hand grenades, shrapnel, and blast waves. A 0.25-inch armored roof existed only over the driver and radio operator, while the other 8 men remained unprotected from attacks from above. In the field, crews often installed extra metal sheets or mesh on their own to prevent grenades from landing inside the hull. In the winter of 1941, during the battles near Moscow, the offensive ground to a halt, with air temperatures dropping to -22 degrees Fahrenheit, operating the machinery became incredibly difficult. Engines required long warm-ups with blowtorches before they could be started. The standard heating system, which piped warm air from the engine to the feet of the driver and radio operator, proved ineffective. The troop compartment was unheated, which led to hypothermia among the personnel. Nevertheless, the vehicles continued moving along snow-covered roads, providing support to tank units. By the end of 1942, production volumes reached dozens of units daily. More than 10 factories were involved in the process, which led to structural differences between vehicles of the same model year. Variations were seen in road wheel tires, front wheel designs, and mounting hardware. This variety of modifications created significant difficulties for logistics services when ordering spare parts. In the fall of 1943, preparations began for the release of the Model D, a modification aimed at radically simplifying the design. Engineers stripped away non-essential elements, keeping only what was strictly necessary. The hull was widened to increase useful volume, and welded seams completely replaced the old riveted joints. The rear armor plate became flat and angled, which made assembly much less labor-intensive. The part count dropped by a third, and the production time for a single unit was cut in half. Industry went into overdrive to meet frontline demands. Factories ran around the clock, utilizing labor from occupied territories. Introducing this simplified model allowed production numbers to soar, doubling the monthly output. Later, specialized versions based on the standard chassis appeared. They mounted 80mm mortars that could fire directly from the vehicle. The crew could strike quickly and change position to avoid return fire. Anti-aircraft variants were fitted with 20mm automatic cannons on rotating mounts. These machines provided cover for convoys against air attacks and could also engage lightly armored ground targets. They even returned fire against enemy ground attack aircraft. Flamethrower versions had a firing range of up to 100 feet, allowing them to destroy fortified points. However, operating these machines came with high risks. Damage to the fuel tanks often led to the loss of the vehicle and the death of the crew. Engineering modifications were designed to transport sappers and special equipment. Ambulance vehicles were used to evacuate the wounded, equipped with stretchers and medical supplies. In total, 23 official modifications were developed based on the Sd.Kfz 251, not counting the various alterations made directly by the troops. Field workshops created non-standard modifications, often as one-off examples. Some armored personnel carriers were fitted with French anti-tank guns, others with captured Maxim machine guns. There were vehicles with makeshift armor reinforcement, homemade turrets, and wooden superstructures for protection against the weather. In North Africa, the Sd.Kfz 251 was used by Rommel's Afrika Korps. The wide tracks provided mobility on the sand, and the open top eased working conditions for the crew in the high heat. British troops called these machines Hanemags, which was technically incorrect, as the Hanemag firm only produced the hulls. During the Battle of Stalingrad, the advantages in maneuverability were nullified by the conditions of urban combat. Soviet infantry used tactics to hit the vehicles from close range with bundles of grenades. The thin armor was penetrated by DSK heavy machine guns. A significant number of these vehicles were left on the streets of the ruined city. During the Battle of Kursk in the summer of 1943, the half-tracks delivered Panzer grenadiers to the front line. The machines crossed minefields behind sappers, deployed their troops and retreated under fire. Vehicle losses during this period were high. German designers attempted to mount 75mm assault and anti-tank guns, turning the Sd.Kfz 251 into a kind of self-propelled gun. However, the overloaded chassis and weak armor made these modifications vulnerable and ineffective in battle. After the Allied landings in Normandy in 1944, German vehicles were used to redeploy forces across different sectors of the front. Enemy air superiority made moving by day dangerous. These open-topped vehicles were vulnerable to attack aircraft. By the spring of 1945, production kept going, despite airstrikes on industrial targets. Assembly was done using whatever scraps were available, using simplified parts and improvised mounts. This led to a drop in quality, but there was simply no alternative. During the Red Army's advance, a large number of half-tracks were captured as war trophies. Soviet troops used them in reconnaissance units and later deployed them by the company. They painted identification markings on the vehicles to avoid friendly fire. American specialists also studied captured Sd.Kfz 251s, comparing them with their own M3 half-track. Tests showed that while the designs were different, the basic performance specs were quite similar. The American M3 had a higher silhouette, which made it an easier target but allowed it to carry more troops and cargo. Armor thickness ranging from 0.3 to 0.6 inches, and the power of their gasoline engines were comparable. Both vehicles featured an open troop compartment. The American M3 platform was more successfully adapted for heavy weaponry, including 75mm and 105mm howitzers. Similar German projects were less successful due to the limited load-bearing capacity of their chassis. However, the Sd.Kfz 251 outperformed its American counterparts in off-road capability, thanks to a superior track design. The Battle of Berlin marked the final stage of active use for these German half-tracks. The vehicles were used to barricade streets and served as stationary pillboxes, only to be destroyed by enemy tank and artillery fire. Crews fought on with no way to retreat. The events of May 1945 brought the combat history of these machines during the war to a close. But the story of the Sd.Kfz 251 didn't end there. In the post-war period, Czechoslovak engineers made use of the remaining German equipment. The Tatra factory in Kopřivnice, which had previously manufactured the hulls, received an order to build an armored personnel carrier for the new state's army. They took the proven design as a base, but made substantial changes. The model was designated the OT-810 and entered mass production in 1950. While the general geometry of the hull remained the same, the running gear was radically modernized. Instead of the original tracks, they installed tracks with pin engagement, which were much more reliable, and the drive sprocket was redesigned. The power plant was swapped for a diesel engine, solving issues with fuel consumption and high fire risk. Diesel fuel reduced the chance of fire, and the vehicle's range nearly doubled. The electrical systems and radios were replaced with more modern equipment, meeting the standards of the Warsaw Pact. The Czechoslovak army received hundreds of these vehicles, using them in exercises and for border patrol until the late 1970s, when they were finally replaced by newer technology. A design developed in the 1930s remained in service for nearly half a century. Today, these Czechoslovak vehicles are often used in historical reenactments, standing in for the original German half-tracks. The resemblance is striking, but experts can identify the OT-810 by its distinctive drive sprocket and tracks. These vehicles have survived in much better technical condition than the original German models. The American M3 half-track also saw long-term service, being exported to various countries. These vehicles were used in conflicts in Korea, the Middle East, and Latin America. The last M3s were retired in 2013, 70 years after production began. The frame chassis of the Sd.Kfz 251 represented an engineering compromise between strength and weight. The steel frame bore the hull's load while remaining light enough to ensure mobility. A superstructure was mounted to the frame, and the armor plates were fastened to that, which simplified repairs. A damaged section could simply be cut away and replaced with a new one. The heterogeneous armor consisted of metal layers with varying hardness. The outer layer was hard to shatter bullets, while the inner layer was more ductile to absorb the energy. The flaw, 0.25 to 0.3 inches thick, offered protection against shrapnel, but was vulnerable to anti-tank mines, forcing crews to steer clear of unchecked terrain. The Maybach engine was situated in the front compartment, behind a steel bulkhead. The six-cylinder unit, with a displacement of 251 cubic inches, delivered 100 horsepower at 3,000 revolutions per minute. The carbureted engines on this equipment proved unstable in low temperatures, which often led to the spark plugs getting flooded with fuel. Mechanics were forced to carry spare sets and swap them out regularly during the winter. The 42-gallon fuel tank was positioned inside the frame, beneath the floor of the fighting compartment. This layout posed a high risk of fire if the armor was penetrated, but it freed up usable space in the troop section and lowered the center of gravity, which improved the vehicle's stability. The control system was a combination of a steering wheel for the front axle and levers that regulated power delivery to the tracks. For gentle maneuvering, the driver used the wheel, just like in a car, but for a sharp turn, braking was applied to one of the tracks. The pneumatic brake system was reliable enough, though in freezing conditions it required constant purging to remove condensation. The steerable front wheels provided traction on hard surfaces, reducing the load on the track mechanism and saving fuel. On rough terrain, the wheels offered little resistance, while the tracks did the heavy hauling. Broad tracks distributed the vehicle's mass, about 3 tons, over a large area, providing off-road capability that standard trucks couldn't match. The road wheels were fitted with rubber tires to cushion impacts on uneven ground. However, the use of components with varying designs from different manufacturers created difficulties with standardization and parts supply. Repair crews often resorted to cannibalizing road wheels from other vehicles and using improvised materials to restore the machines. The troop compartment was designed to transport 10 fully equipped soldiers with their personal weapons and ammunition. Positioning the infantrymen on benches along the sides, with their backs against the armor plates, created ergonomic discomfort during long marches. Personnel often preferred to travel standing up, holding onto the sides, which allowed them to bail out of the vehicle faster in a critical situation. The doors in the rear folded down, forming a ramp for rapid deployment. A radio operator manned the transceiver station, with a whip antenna mounted above the front plate. Communication range was up to 3 miles on the move and up to 6 miles at a standstill with the antenna extended. Command variants were equipped with multiple radios, operating on different bands, allowing for the coordination of several units. The standard armament of the basic version included 1 or 2 7.92mm machine guns on pintle mounts. Firing was done from a standing position, leaving the gunner's upper body exposed. A combat load of 2,000 rounds in belts was stowed in boxes beneath the seats. To increase firepower, crews sometimes utilized additional captured weaponry. Over the course of the conflict, the industry turned out more than 15,000 armored personnel carriers of all variants. Yet despite these significant production numbers, it wasn't enough to fully equip the troops. A large portion of the infantry continued to travel on foot or in trucks, leaving them exposed to high risks from shelling while on the move. The Sd.Kfz 251 became one of the most widely produced and recognizable armored vehicles of World War II, captured in countless historical records. These machines saw service throughout the entire conflict in the European theater. Despite design features like thin armor and the lack of a roof, the vehicle provided infantry with the level of protection and mobility needed to carry out their missions on the battlefield.